It is given in the question that two cylinders whose weight is 200 Newton and 50 Newton are placed in a roof. And also it is given in the question that the diameter of the first cylinder is, the bigger cylinder is 100 mm and the smaller cylinder is 50 mm. So it is asked in the question that we have to find out the reaction force at the contact points. So first we have to check what are the reaction forces. So here this point is this point is G, this point is C, this point is E, and this point is F. So here, because of this contact, there will be a reaction force which will be perpendicular to this contact surface. So here it will be perpendicular to this F. So here it will act like this. This is RF, weight is acting vertically downward, and here it is perpendicular to this contact point E. So this reaction force, it will exert force. The cylinder A will exert force on B, and also B will exert force on A. So it will act vice versa. So here RE will act on A like this, and it will act on cylinder B like this. And here at the contact point C, there is also a reaction force RC which will act perpendicular to this surface. And here also at the contact point D, it will act perpendicular to this surface, contact surface. So it will act like this. So it is given that its length is 120 mm, and the angle of inclination, this angle is up to here, up to this inclined plane, inclined surface, it is inclined at an angle 45 degree. So to find out, we can solve it using, this is a type of equilibrium problem, so we can solve it using Lamy's theorem. So for Lamy's theorem, we have to first find out the angle between the forces. So to check the angle between forces, we have to check different angles. So first, to find out this unknown angle, let's join the center point of smaller circle and larger circle, that is smaller sphere and larger sphere. So we have to join the center point of two cylinders. So up to here, this is the radius of smaller cylinder. So diameter is 50 mm. So radius is 25 mm. And here to here, it is the radius of larger cylinder. So larger cylinder diameter is 100 mm. So radius is 50 mm. So here to here, total distance is 25 plus 50, that is 75 mm. Got it? And what is the distance of this O1G? O1G, here to here, it is the radius of smaller cylinder, that is 25 mm, and here to here it is the radius of larger cylinder, that is 50 mm, and total length is 120 mm. So from 120, if we will subtract this length and this length, we will get this length. So it is 120 minus 25. So it is 120 minus 25 plus 50. So that is 45 mm. So O1G is 45 mm. And O1O2 is 75 mm. That is the summation of the radius of two cylinders. So this theta value we can calculate now easily. So cos theta is base by hypotenuse. So base is 45, hypotenuse is 75. So what is theta value? Cos inverse 45 by 75, that is 53.13 degree. So here you got the value of theta. Now we will draw the free body diagram for cylinder A. So here weight is acting vertically downward, that is 50 Newton. So we will draw this line. From this horizontal, there is a normal reaction at contact point F. So this is RF, and this reaction force is acting like this. So from the transmissibility theorem, we know that if we will slide the force along its line of action, its effect will not change. So we will slide the reaction force RE. So RE will act like this. So we know this value of theta, that is 53.13 degree. So if this angle is theta, this will be theta. So this will be 53.13 degree. So what is this value? We know the angle of straight line is 180 degree. So here to here it is 180 degree. So from here to here it is 180 minus 53.13. So let me check this value. 180 minus 53.13. 126.87. This is 126.87 degree. And we know that weight always act vertically downward. So here to here it is 90 degree. And also here to here it is 90 degree. Total angle is 90 degree. So now we'll draw we'll use Lamy's theorem. So total angle between RE and 50, that the weight is 90 plus 53.13. So 90 plus 53.13, that is equal to 143.13. So this total angle is 143.13 degree. So we'll use Lamy's theorem. So at this point, center point O1, three concurrent forces are acting. So here 50 divided by sine, that is the angle between RE and RF, sine 126.87 equal to RF divided by sine of angle between RE and 50, that is RF divided by sine 143.13 equal to RE divided by sine of angle between RF and 50, that is 90 degree. So here we can calculate the value of RF and RE. So RF is 50 by sine 126.87 into sine 143.13. So let me check the answer. 50 divided by sine 126.87 that is 62.5 into sine 143.13, that is equal to this, and RE equal to 50 divided by sine 126.87 into sine 90. Sine 90 value is 1, so RE is 62.5 Newton, and RF is, let me check the answer, 62.5 into sine 143.13, 37.5 Newton. So from here we got the value of RF, that is the reaction force at the point F, which is 37.5 Newton, and RE, which is the reaction force at this contact point E, so that value is 62.5 Newton. So next we'll apply Lamy's theorem for this block B. So we'll draw the free body diagram for block B. So here we'll find out the reaction force for this block. For this we'll draw the free body diagram. So free body diagram, RC is the normal reaction which is acting at this point C. This point is C at this contact point. So this is RC. RD is the normal reaction at this contact point D. You can see this is RD, and weight is acting vertically downward, that is 200 Newton, and also this reaction force at the contact point E, RE is acting like this. So RC is normal to this contact point C, RD is normal to this contact point D, RE is normal to this contact point E, so it will act like this, and weight is 200 Newton, that is acting vertically downward. So first we have to find out this angle. So this angle, this is acting normal to this contact point T, so we will extend this line. So here to here it is 90 degree. So we know that this angle and this angle are same parallel angle. So if this is 45, then this is 45, then total angle of a triangle is 120 degrees. So this is 90, this is 45, means this is 45. So this is 45 means we'll extend this. So this angle is 45. If this angle is 45, then this angle will be 45. So if this angle is 45, this angle will be 45. So the RC and RD, the angle between them is that is RC and horizontal line is 45 degree. And here this angle theta is, we got 53.13 degree. So here to here it is 53.13 degree. This is 90. So this is 180 minus 53.13 plus 90. That is, I have calculated 36.87 degree. So this angle is 36.87 degree. So here we will come to this. So this angle is 36.87 degree and this angle is 45 degree. So if this is 36.87 degree, this is also 36.87 degree. So rest here to here is 90 minus 36.87, that is 53.13 degree. So here to here also 53.13 degree. And so here four forces are acting. So we'll use resolution method to solve to find out the reaction force. RE we have calculated earlier. So this value we have got 62.5 Newton. So here to here 45 means here 180 minus 45, that is 135. So we'll resolve the forces. So net horizontal force for equilibrium, net horizontal force equal to 0 and net vertical force equal to 0. So what are the net horizontal forces? So we'll resolve first along x-axis. So RC is acting like this and its angle is 45 degree. So if we will resolve it along horizontal axis, its direction will be along positive x-axis. So its sign will be positive. So RC cos 45, and RD is acting like this. It is acting along negative x-axis. So minus RD, and 200 Newton is a vertical force, purely vertical, weight is purely vertical, so its horizontal component is 0 plus 0. RE is acting like this. If we will resolve it with the horizontal axis, it will act positive x-axis and its angle of inclination is 53.13 degree. So plus RE cos, RE is known value, we know RE magnitude 62.5 cos 53.13, that is equal to 0. Similarly, we will resolve the vertical forces. So if we will resolve RC, then along vertical axis it will be sine component. So RC sine 45, it is acting along positive y-axis, so it will be positive RC sine 45 degree. RD is horizontal force, so purely horizontal, its vertical component is 0. 200 Newton is purely vertical and it's acting along negative x-axis, sorry, negative y-axis, so minus 200. Similarly RE, if that is inclined 53.13 degree with the horizontal, so its vertical component will be sine component and its arrowhead is like this, so it will act like this. So it will act along negative y-axis, so minus RE value is known, again I wrote it like this, so 62.5 sine 53.13 degree and its sign is negative, equal to 0. So here only two unknown are there, RC and RD, and two equation are there. So two equation, two unknown, so you can easily solve it. So after solving this, you will get the value of RC and RD. So here you got 4 reaction forces at 4 contact points. So I think you can solve these two equations and calculate the